please welcome this year's Richard Dimbleby Lecturer, Sir Tim Berners-Lee.
Thank you. Thank you. Thank you, Jonathan, and thank you to the Dimbleby family for continuing on Richard Dimbleby's legacy. As you may know, Richard Dimbleby started reporting in 1936. He was the BBC's first war reporter, and then its leading TV news commentator. What's less well known is that he's also a pioneer in high tech. He did the first live television link across the English Channel. He was a big influence in the telecommunications revolution and was fascinated with its potential. Richard Dimbleby was a man who had the vision to see potential in technologies that would enable communication and information sharing. So, to a certain extent, he was very much a man after my own heart. His legacy lives on in his family, two of whom, David and Jonathan, have followed his footsteps to become major broadcasting figures in their own right. And it lives on in this lecture, of which I'm very honoured to be a part. So today I will talk first about my original vision for the web. I'll then talk about where it is today, the thorns as well as the roses. And because those thorns worry me, finally I will discuss what we all need to do to make an important, basically a mid-course correction for the web. I grew up in London. I'm one of 4 children, and my parents were mathematicians who actually met on the team building the first computer in Manchester, the Manchester Mark I. My dad analysed systems, and my mum wrote programs. Mum could read a program by holding the 5-hole paper tape up to the light, and if necessary, she could edit it with scissors and sticky tape. Dad would explain computing to lay people. He would explain 1010 binary code in terms of pennies, halfpennies, and farthings. If you don't know what binary is, well, it's like pennies, halfpennies, and farthings. If you don't know what pennies, halfpennies, and farthings are, well, it's like binary. They and their colleagues were all filled with a fresh excitement about the fact that when you program a computer, what you can do with it is limited only by your imagination. Alan Turing, in fact, had showed, as a mathematical fact, that any computer could imitate any other computer. And so, in a sense, all computers were equivalent. And so then the result was that it didn't matter which computer you were using, you could tackle exactly the same set of challenges. I've got much to thank Mum and Dad for. The spirit of building your own version if you didn't like what was provided to you, the knowledge that everything was maths inside, and the drawing of diagrams on whiteboard walls well before whiteboard walls were even a thing. One of the books on the shelves of my parents' home had the title, Inquire Within Upon Everything. It was a Victorian advice novel, advice on everything from how to remove clothing stains to how to invest money. Its title, Inquire Within Upon Everything, stuck with me. More about that later. While my parents are no longer with us, they've left me and the computer industry a legacy of their excitement about the potential of computing. A magical aspect, in a way, of my generation was that the sort of electronic hardware that we could buy with our pocket money ramped up every year. So in primary school, my friends and I played with electromagnets made of nails and wire. And then in the 50s, the transistor was invented. So my school friends and I made fun things from transistors, model train controllers, steam whistles, and so on. And then when we were in school, the integrated circuit arrived, and so we could make more and more complicated circuits. And so, in fact, at that point, at the end of high school, we could have used those integrated circuits to build a whole computer, but it would have been a really big project. But then, in 1976, bing, the single-chip microprocessor comes along. I can buy a M6800, which has got 2-inch long chip with all of the processor on that chip. So then suddenly, all of the computer you can build out of pocket money. So I did. Maths was my best subject at school, but in fact I had more fun with electronics. I ended up doing, at Oxford I did physics, And then, after Oxford, I went down to the south coast, joined a big telecommunications company in Dorset. And then they quickly moved through into the local world of startups and consulting. I was an engineer at the boundary between hardware and software, which was a great place to be. In 1980, I went for my first 6-month stint at CERN, and then in 1984, I went back there, in the end, 10 years. CERN is a wonderful place. If you haven't been there, you should visit. It's an international high-energy physics lab, a huge project in terms of high-tech engineering, control systems, and data analysis. It's also home to a few thousand people from all over the world who bring their own language, their own computer language, their own computers. Interestingly, there was no strict rule at CERN, no hierarchical management which said everybody had to use the same sort of computer. So each team used whatever hardware and software systems it felt were best for them to use to build their different part of this huge, big puzzle. So that meant that the documentation systems and the online help systems each team developed were completely different. For anyone trying to work with more than one group, or anyone working on connections between the different systems like me, this made life really difficult. Actually, the best way I found around this difficulty was to ask questions at the coffee area. That was where I could be introduced. I could ask about one system, and then you could say, oh, you need to talk to this guy, because he developed that system. And so, in fact, in the coffee area, I could make the connections, but figure out all the different pieces I needed to use to build my bit of it. So CERN had the benefit of huge diversity of people, but the challenge of the diversity of the computers that they brought in, not to mention built themselves. But it also, by 1984, it had the makings of a solution as well. Because not only did we at CERN have large screen Unix workstations, but those computers were starting to become, bit by bit, for the first time, connected to the internet. As you might remember, it was invented 20 years before the web. So we're talking 1969. 1969, DARPA, the US Defense Agency, funds connections between local area networks so that all the local area networks at different universities end up being directly or indirectly connected to each other, the internetwork. Vint Cerf and his colleagues wrote the rules, the protocols about how packets of information will be directed by each computer down the right link to get to where it's going, just as post offices direct postcards to other post offices. 20 years on, in 1989, I was thinking about the web. This series of networks had started to stretch across the globe. People had adapted email to run over the internet, but the other ways of using it were pretty technical and not suitable for general use. There were no web servers, no web pages, no web browsers. Meanwhile, at CERN, you might have been in a meeting, somebody might have handed you the agenda on a piece of paper, and you realized that probably by that time it wasn't hand-typed, that came off a word processor on a computer. So somewhere there was a computer with a file from the agenda for the meeting, and probably nowadays that computer was more and more likely to be connected to the internet. So why couldn't I get the agenda electronically over the internet? Back in 1980, when I was first at CERN, I'd come up with a system of linked notes called Inquire, short for Inquire Within Upon Everything. Remember that book on my parents' bookshelf? Inquire, the program, aimed to capture information on and connections between systems, documents, people, and things. It was also a fun prototype to play with. When I came back to CERN in 1984, I remembered the usefulness of Inquire, but now my idea was fundamentally different. My idea now was not to build the biggest, best single documentation system. No, it was to build a whole new world in which all the existing documentation systems, warts and all, could coexist and be interlinked. I found that the idea of hypertext, pages with links, was the key. Different though all these systems were, that when you looked at the screens, each screen you could think of as just being pages with links. Whether they were menus or catalogs or indexes, each page of each of the systems could be thought of as a hypertext page. So I started thinking and talking and maybe confusing people a bit with my ideas about what the system of useful information sharing could be. One day my boss, Mike Sendell, said, "You know that hypertext thing you've been talking about? Can you write a memo about it?" So I wrote up a memo. I drew out circles and arrows, chart of how I was thinking about the thing. I tapped a few pages explaining it. But CERN didn't really have a process for approving new global hypertext projects. Physics projects, yes, but not global hypertext projects. But meanwhile, Mike knew that I'd wanted to buy the next computer, that neat computer that Steve Jobs made when he left Apple, Black Magnesium Cube. It was supposed to be a real good development system, and that gave Mike an excuse to let me work on the project. He said, "We'll buy the next. You will need to evaluate it. You'll need to evaluate it by building some program. Why not? Why don't you just try out that hypertext thing?" With a glint in his eye. So 10 years later, after Mike had died, his wife Peggy found that original copy of my proposal. It's only then that we came across this now famous piece of handwriting in the top right-hand corner of the cover, which read, "Vague but exciting." Thank goodness when he read it, he thought it was vague but exciting. Instead of, if he'd have thought exciting but vague, maybe he wouldn't let me do it and we wouldn't be talking about it now. So that's how it started. The next computer arrived in September. I wrote the web server code. I also wrote the code for what we now think of as a web browser, but importantly, it was both a browser and an editor. You could read web pages with it, but also you could edit and format pages, and you could save backlinks between them. I called it worldwideweb.app. The design of the web involved making a new protocol for the internet, a new format for those documents, and all of the interlinking material that you'd go through in order to find them, and a new naming system for all of the documents. So URLs is what you call now typically people call these names. I called them UDIs back then, Universal Document Identifiers. HTTP was the Hypertext Transfer Protocol, and HTML, Hypertext Markup Language, was and then at that point, really, really simple format I designed for making a hypertext page. I had the code working by the time CERN closed down mid-December for the holidays to save energy. Those were exciting times, but actually not mainly because of the web code. The main thing, the most exciting thing with our first baby was due on December 24th, and she was in fact born on January the 1st, 1991. One of the most important parts about the World Wide Web app to me, in fact, was that fact that you could use the same program to read the document, and then you could edit it. You use the same program to indeed make new web pages. People had to be able to add new ideas, new information, new connections very easily. Otherwise, how was the web going to stay accurate and up to date? And how are we going to capture new ideas as we're brainstorming? There was a challenge, I imagined. Imagine someone on one side of the world have half of a solution to a problem in their head, and someone on the other side of the world has got the other half of the solution in their head. Then how could these people find each other and put their parts of the solution together and solve the problem? How could they do it? Well, through people being able to make links really, really easily between different ideas, and then through people that they'd never met, finding those links and following them and making the connection. That was really, really important for a way, this collaborative way that I wanted the web to be able to work. In fact, since the early days, I'd also been really fascinated by the way the human brain will make random associations. You come here and you listen to me, and maybe you had a particular type of coffee, and then later on you remember what I said, but not because of what I said, but because you smell the same sort of coffee, and your brain takes you back to where you were last time you did it. The brain has got this way of doing it, connecting these unconnected things. And the Inquire system, actually, that system of cards I did in 1980, that had the ability to link any arbitrary things. So the web involved asking everybody to give one of these URLs, one of these things starting with HTTP, to everything, to every resource. That is a really big ask. You can't also ask really anything else at all. You can't also ask that they should all use the same type of computer. You can't also ask that they should use the same language. You can't also ask that they should store their data in a particular format. Lots of the other documentation systems out there forced you to work in a particular way. The web couldn't do that. Also, by the way, I couldn't ask them, you should give everything a URL and you should pay me a royalty too. That wouldn't have worked. The web wouldn't have taken off. So the web had to be an open platform with no attitude. It had to be independent of language, type of computer. It had to be independent of operating system, independent of the type of document, like it should take scribbled notes and peer-reviewed papers to the same extent. Independent of culture. It had to work also as well as possible for people with disabilities. So for people building on the web, I wanted them to find that the web as a platform to build on was an open, permissionless space. Nobody would have to ask me permission. Just as I built the web on top of the internet, I found the internet to be a permissionless space. I never had to go and ask anybody like Vintsurf whether I could start the web. People don't have to ask me when they want to start websites. Permissionless space is a really important part of this whole story. So those are the design goals of the system, if you like. To have a universal, read-write, open, permissionless information space that fostered collaboration and broke down the barriers between all those existing systems. So at the end of 1990, the first web browser and the first web server, info.cern.ch, were working. Now, in principle, anybody could use the web. It took off, but not instantly. Colleagues and I had to fight hard for it within CERN at first, and then within other organizations, and then in the world. Robert Caillou was the first person who really bought into the web, and he made it his mission to get others to join in. Critical for that process was that CERN's declaration, after long pressure from Robert and me, in April 1993, that the web would be free of royalties. CERN promised not to charge royalties on the web. The number of hits per day on the first web server started off as about 100. A year later, I looked at the logs, and they were about 1,000 hits a day. A year later, we looked at the logs, and they were about 10,000 hits a day. A year later, we looked at the logs, and they were about 100,000 hits a day. Right, now when people talk about it grew exponentially, often they're exaggerating. When something goes up by a factor of 10 every year, that is what we call exponential. We knew that this was serious. People say, when did you realize it was going to take off? Well, it was just a continual explosion. So suddenly, there it was, in the hands of all these people, out there for them to do whatever they wanted with it. I've never been in a bobsled myself, but when you see the bobsled team on TV, it seems as though the bobsled thing is about first pushing really, your team pushes really hard, and you have to push really hard to get it moving, and then it picks up speed, and it goes faster and faster and faster, and then there's a time as it picks up speed and the track starts to go downhill that you really have to jump in and steer. And that time for the web was 1993 for me. That was the time when somebody had to jump in and steer. When I turned the protocols of the web over and just I put the specs out there on the web, there were these minimal rules for a basic system, but it had to evolve. And I felt there was a need for the developer of the web to be overseen so as to make sure that it would head in the best direction for everybody. I set up a standards body for the web at MIT at INRIA called the World Wide Web Consortium, or WWC, to do just this. Crucial thing there at WWC is working groups, companies, individuals get together to develop technologies and share their thoughts and concerns on the issues in the spirit of consensus, to arrive at consensus. And big companies and small organizations operate on the same level playing field. So all perspectives in the design are considered. The key here was that WCC, the consortium, allowed the power of the web to grow, but crucially, to keep it one web. And it grew. There have been some good things out there on the web. If you ask somebody out in the street, probably they might pick on Wikipedia. Wikipedia, launched in 2001, embodies a really neat ethos of working together towards ever and ever higher quality. Initially, everybody could just write to it. It was utopian, read, write, play space, but they rapidly changed it so they had protocols and structure and rules. But today it's arguably one of the most used amazing information sources in the whole web. Similar, actually, but less known well, is OpenStreetMap. OpenStreetMaps are like Google Maps, but it is open source. It is contributed, just like Wikipedia, it's contributed by people, including me. Some of the trails in Massachusetts, I put there because they weren't there. There are now, it's a pretty good resource, particularly for trails and sports and things. And when the earthquake struck Haiti, there was a problem that the volunteers solved. They immediately pushed an update to the area around Port-au-Prince. In fact, over 24 hours, they took satellite images and just worked to update the map. So they also had new things like blocked roads and a hospital ship in the middle of the harbour, things like that. And OpenStreetMap is often used by agencies out there in the field now. Another neat example of stuff on the web is the whole open source movement. The web initially really benefited from people just writing, contributing open source code. All my code originally at CERN was open source. Open source actually wasn't invented then. It was free software, it was open software. Now we call it open source. Open source is software which you don't have to pay for, which is contributed generally by random people. If you're an open source coder, you typically don't initially write code at all. You search for it. You search for where somebody else has written it, and you find where that is, and you use their version instead. So when you're coding stuff, because so much stuff has been written, just by searching for people who've already written the function that you want, you make progress hugely fast. So it's just a very, very much more efficient way of working. You save that time rewriting the code that has already been written. So those are some neat things. Open source, Wikipedia, OpenStreetMap, what's not to love about the web. So for those roses, there are the thorns. And unlike 10 years ago, go out on the street and people would have told you about the roses. Now they probably tell you at least as much about the thorns. These things might include privacy, data rights, security, tracking, free speech, hate speech, political advertising, and so much more. So in terms of what I'm concerned with, there's more than one thing which keeps me up at night about the web. Of the various attacks on the web, perhaps the simplest is blocking and censorship. Free speech is important, and it's threatened in many communities by blocking and by censorship. There are governments around the world who are blocking opposition parties' content online. There are governments filtering out things which seem to be philosophically counter to the regime. There are governments who are randomly shutting down access of their citizens to the internet in terms of crisis. This obviously has a dramatic effect on the value of the web. In a way, it's a measure of the strength of a government, the extent to which it allows its opposition and foreign sources to speak. I thought a lot of people hoped that when the web came along, the value of openness on the web would have prompted a new progressive openness of governments that previously didn't do this very well. In many places, we have certainly not seen this. Another problem people are perhaps increasingly aware of is, particularly more recently, has to do with the fact that much of the web has insufficient accountability. There is, by design, no approval system people need to go to share their information online. They don't have to come and ask me to post things. So as soon as somebody posts something on the web, it can be viewed by a huge number of people. So this seemed to work when individual people posted as individuals with their own reputations at stake. But now we have systems which create fake accounts, and there are millions of automated systems, bots we call them for robots, on social media platforms spreading messages of hate and conflict. Because of this, misinformation has been spreading rampantly. There are not enough systems holding these people and this information to account. They should be testing the truthfulness of information individuals and organizations are putting online. Then we have issues of tracking and spying. Using people's browsing information to inform on and potentially manipulate or even arrest users, depending on what sort of government you are. And of course, in democratic societies, law enforcement agencies quite reasonably demand the ability to monitor citizens more and more in the online space, and citizens quite reasonably push back. There's a balance and a tension between monitoring by police and law enforcement and privacy. Privacy is a fundamental right. Citizens should have their civil liberties protected. They should be able to share information, limit the collection and control of their personal communications and data. The need for privacy and anonymity is especially clear in places where LGBTQ people, activists, journalists, and their sources particularly, are under threat and need protection. We should be able to use the web without feeling that somebody's looking over our shoulder. And at the same time, we have to be conscious of the potential downsides of anonymity. Governments will need to be able to use lawful and proportional methods to identify and punish bad actors who are creating the harms I just spoke about. When governments have access to citizens' use of the web, the process should be transparent and clear on how government and law enforcement access and handle this information, and it should be limited, proportionate, and subject to the rule of law. Collecting users' data by companies can also be intrusive and exploitative. Collecting their browsing history, clicks, likes, and IP addresses and locations are currently being collected in order to gather information on web users, sometimes to provide useful services that consumers expect, but also for abusive practices. For example, targeted advertising can be very useful when a user is looking for a commercial product. However, today, data information is being used for more than commercial advertising. We had a sobering example of this coming to life with Cambridge Analytica. In 2014, Cambridge Analytica collected personal information from 50 million Facebook users. They said it was to be used for scientific research. They, in fact, used it to create psychological models to exploit what was known about a huge number of people to target them with personalized political advertisements. The company was hired by the 2016 Trump campaign and other political campaigns in the US and the UK, including the Leave campaign. The uncovering of that scandal opened the window, I think for many people for the first time, on that complicated world of data being used in all kinds of weird, devious, and complicated hidden ways. By this point in time, 30 years on, if you'd asked me 30 years ago where we'd be, I kind of would have hoped that we'd be using web tools effectively to promote and facilitate democracy. What we see now with the exploitation we saw with Cambridge Analytica, the spread of misinformation, the lack of accountability, the blocking and censorship by governments, this is not what we are seeing. The web could be a place where politicians are held to account, where more functional discourse happens between countries, and where communal decisions are made about what's best for humanity. The web does not have to stay the way it is now. It can be changed. It should be changed. It needs to be changed. Don't expect the future to be just more of the same. It will be either better or worse. It's always been changing. But the future doesn't change itself. It's changed by people. To make sure we have the web we want, we all have a role to play. First of all, developers. If you're a developer, I want you to build things for democracy and for civil debate. I want you to build systems that are accountable. I want you to make it easy for users to find out where information comes from. I want you to think about creating revenue models not based on data collection. There are lots of them. And always, always think about the unintended consequences of what you're building. Though a program or app could have great potential to make things easy for your users, think about the ways it can be manipulated and misused, and do your best to mitigate those in the design. Part of the solution, I think, is a technical development that I've been working on called Solid. This gives users complete control of their data. It does that by decoupling the data from the applications. It's still the web, but it's the web with a few more things added and a few assumptions overturned. We add a global identity system so that instead of having to sign into everything with Google, Facebook, or Twitter, you can sign in with your favorite Solid provider and you won't be tracked. We add ubiquitous sharing control so that you can share anything with anybody, no matter which social network they happen to be part of, social networks. We also, with a Solid account, you get some storage. You get some sort of personal cloud storage, like a USB key in the sky. We call it a Solid pod. It's a space that's yours. All the data that goes in it, you control. And here's where we flip some of the assumptions of the way apps work at the moment. When you start a Solid app, instead of the app storing the data itself, it stores it on your pod. So you use the app, you choose which app to use, and you choose which pod to use. And then, because all of the data goes into your pod, or your various pods, then you have complete control over the data, because that's the way pods work. They allow you to share anything with anything. It starts off being about privacy, but actually for most people, what's exciting about it is creating a world in which you are empowered to share anything with anybody without worrying about which social network they're on, for example. You may see the web as just a tool, something that you don't think about, you don't question, you don't feel that you have any control over at all. But there, you're wrong. Even though you may not think that way, every one of you here has already been a part of creating the web. Every time you make links, every time you post or like a photo or a comment, you are part of creating what's on the web. Even when you click on a link, your action on selecting that link affects the choices of links others will be given later. So you're already part of affecting the web. How should you do this constructively? I want you to be careful and thoughtful and positive. I want you to beware of what you're putting out on the web. Be mindful about what you're sharing, liking, and passing on. If this means taking a moment before reposting or retweeting, take that moment and think about whether this is something you're going to be proud of the next day. You're part of a bigger system. And what you endorse goes a very, very long way. I also want you to be cautious and critical about what you are absorbing from what you see on the web. I want you to question the source of the data that you see. I want you to nurture and respect truthful information sources. When you see something, how you react to it is important. Research says that we are 10 times likelier to retweet an item that makes us angry than one that makes us happy. Are you going to accept any information you see online? Are you going to reply with a heated response? Or will you pause and consider and work towards fostering healthy conversations and harmony? It doesn't stop with our personal behavior either. To get the web we want, we also need to see changes in technology and changes in laws and regulations. And that means governments and companies have a responsibility to make sure that the web continues to be a force for good. Citizens have a vital role to demand that governments and companies take the right action and hold them accountable. We need governments to adopt digital policies that protect human rights. We need companies to design their user interfaces so that they empower people, not manipulate them. And we need citizens to be active participants in their online experiences and create content that enriches humanity. And to solve the world's complex problems, we need collaboration between all these three parties, organizations, governments, companies, and people, on a grand scale. That's why, last year, I called for a contract for the web that would bring together governments, companies, and citizens from across the world to take action to protect the web as a force for good. The contract has been created over the last year by working groups of experts and individuals from around the world who joined the contract a year ago. The contract is a blueprint that sets out new standards for the web we want. Next week, we'll publish the contract for the web, and for the first time, we will have a global plan of action to make sure that our online world is safe, empowering, and generally for everyone. It will provide governments, companies, and all of us with concrete actions we can and must take to build a web that works for all humanity. And it will guide digital policy of the agendas of governments and the decisions of companies as they build tomorrow's web technologies. The best way to change the priorities and actions of those in power is to speak up from every corner of the world and demand the web we want. The contract for the web is being led by the Web Foundation, an organization I founded with my wife Rosemary 10 years ago. Back then, around 20% of the global population was online. Today, more than 50% of the world's population are now online. And the web is turning from being a fun luxury at the beginning to becoming something we have to think of as a human right. The question is, what will the web look like in the next 30 years? Will it be an open space for collaboration, creativity, and innovation that I imagined? Or will it be an altogether darker place? I'm asking for your help. Let's make the online world a place worth living in. I ask you to support the Web Foundation and the other charities and activists that are fighting for your digital rights. I ask you to sign up and support the contract for the web when it's launched next week at contractfortheweb.org. When humanity decides what it's going to believe, then it uses science. When humanity decides communally what to do, then, on a good day, it uses democracy. Science and democracy are both under pressure, partly from a broken web. We need a functional humanity connected by technology. So we need to get the web fixed urgently. For one thing, because climate change is urgent, and we need science, democracy, and global collaboration to fix climate change. So it's urgent. We have to all fight now for the web that we want. Thank you.